Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
Now the next thing I would like to go over is the complexity of features we can identify on prismatic parts. Now to demonstrate this in this webinar, I'm going to use our plugin for SolidWorks, which is VisualCAM for SolidWorks in here. Now as you can tell by looking at this part, there's a multi-level pocket, multi-tiered pocket in here. So there's multiple pockets on this part, and to program this part we could take advantage of our feature detection and machining as well in here. So the workflow is very similar, so make sure you have your machining browser open and then click on Tools and Machining Objects to display the Machining Objects browser. You could then go over to your Features tab under the Machining Objects browser and choose Create Machining Features. So you're now prompted with the Selection Manager. So I'm going to pick the 3 faces. You can also pick multiple faces in here as you see it, and then accept it. Now the features are being identified and detected, and you'll notice that the features that have been identified are automatically listed under the Features tab in the Machining Objects browser. So we have planar faces, we have prismatic pockets. You can see that there's 2 prismatic pockets. The first pocket over here, and then the second pocket, which is down at the part, and then you have the 4 different hole features that have been identified. So the workflow in here to program these would be very similar. So you select, first step is to program a facing operation. So right click on the planar face and choose facing, make a selection for the tool and generate. So the facing operation is now programmed. Now we want to program these pockets in here, so I'm going to select the first pocket feature, program a pocketing operation. You pick your tool. You'll notice that you don't have to even enter in the depth, any of the parameters, because they're automatically derived from the feature. I'm going to pick the next pocket, right click, and choose pocketing. Make a selection for the tool, generate. You'll notice that the toolpath is automatically determined based off the feature, and all the depth parameters are derived from the feature. Folks, if you do have any questions, please feel free to post those questions in your questions panel, and we'll try to get to them. So we now have the toolpaths program for the face, the pocket feature for the step number 1, and also the pocket feature for step number 2. In the next step, we could program these holes. We could use a drilling operation. So right click and choose drilling, and you'll notice that the whole cross-section information appears under the whole features tab in the drilling operation. You make a selection for the tool, specify your cutting parameters, and you'll notice that the depth information is automatically obtained from the feature and generate. Similarly, we can go back and program the other hole features on these parts, where you can program the larger holes. You could program it with a spot drill operation to start with, and then you can go back and add a hole pocketing or hole profiling operation. So in this particular step, I'm going to just choose hole pocketing and specify a tool. I'll use a 1/4" end mill and generate. Now if you have features from additional orientations, you could rotate the view and then select the face, accept your selections to detect features from additional orientation, and you'll notice that there is an orientation that's being added or inserted for each orientation that you select from to identify the features from each of these orientations.
Uday, I want to pause here for a minute and emphasize one point based on a question I just received from one of the attendees. This is regarding the whole feature collector in the feature tree. I just want to make sure that attendees understand that the whole feature collector is basically a collection of all the holes that are similar in diameter as well as depth. So these are the same type of hole that we have detected in the model. And so when we select that whole feature and apply a machining operation to that particular whole feature collector, we can use the same tool, the same cutting parameters to machine the entire set of holes. So that's why we segment these whole features into multiple collectors in the feature tree. I hope that is clear. Thank you, Uday.
Thank you, Joe. So as Joe pointed out, each of these, there's multiple instances or multiple of the same holes for each of these hole features, and they're grouped based on the features that have been identified. And as you can see on this particular part, we have 4 different hole features, and you can right-click and select an operation to learn more about the cross-section of the holes that are being identified. So these 4 holes in here have the exact same diameter and the depth in here. So that's why they're grouped under a hole feature 1. And if there were different depths, they would have been under a different feature in the feature tree.